It's a pleasure to be here. It's a pleasure to see many friends, some with whom I've been corresponding for many years, and suddenly I have the chance to meet them personally. Uh, and for many, we've been meeting. We had never met, for example, with uh, Tom Croat. I mean, we've been collecting in the same places for 40 years, and suddenly we met last year in in Peru, in Ecuador, and now we meet here. So I'm very pleased that for the organizers to have invited such a diverse group, but a group that in the end we are working on the same things. We're interested. We're exchanging a lot of things, and the only way to work is really by group working, not working on your own, but working with a big group. As you can see here, there are lots of people involved in this work. Many of them are not mentioned. We have a large group who are photographing in the field, collecting in the field, and we are trying to promote that they do good photography, make Lancaster plates, and then deposit, hopefully if they have collecting permits, and they can deposit a specimen in a herbarium. So Epidendrum is as Gerardo just said, is the largest genus in the neotropics. I have been calculating 2,400 species, but we've already confirmed about 2,152 because we're describing about 50 species a year. We have a lot of backlog, and the common feature theoretically of the flowers is that the column is united to the lip. This is where you separate the column from the lip. And it has a viscarium. It does not have a visidium. The difference is in the visidium in Oncidiinae and others is a part of the pollinarium, whereas the viscarium, a term coined by Dressler and Gerardo Salazar about 20 years ago, is a part of the rostellum. It's a part of that lamina, which becomes semi-liquid and is taken out by the pollinator first, and then he gets into contact with the pollinium, pollinaria, and that's the way they get glued onto the proboscis, because most of these species are pollinated by moths or butterflies. The other theoretical description is that the column, the lip is welded to the column from the base to the apex. In many species it's true, but there are some where they're only half welded. Here's the anther, and from here to the base it's united, but this is free. And then there are a couple of species, probably made about 8 or 10, which have a completely free lip from the column. It doesn't form a corniculus in any case, so they probably are not pollinated by butterflies. That's a discussion I had with someone there. How a butterfly could use this to maybe stand on the top and get put its proboscis here, get it guided in, and then back out to get the pollinia. I don't know. I don't know how it works. It's something which nobody has ever photographed and nobody has ever seen. But it would be very interesting to see these things with absolutely free columns. And of course, they cannot be set aside because they're monophyletic. They belong to particular groups. They're clearly closely related, but there are exceptions. So we have a lot of exceptions in this case. The cuniculus or the vesicle is very different. Sometimes it's very wide, sometimes it's very narrow, can be very long. This is 25 centimeters, and there's only nectar at the base. So it must be a sphinxid with a very long proboscis to get in there. Sometimes, again, it's wide. Sometimes it has pubescence, especially in front of the stigmatic cavity and around the callus, or sometimes over the callus, sometimes even in 1 or 2 cases over the whole lip. So there are differences, but they don't they shouldn't be used to try to make another genus out of it. As far as the column and the rostellum, here, for example, you have an example where the column wings are involute. I don't know what that stands for. This, for example, looks more like a Scaphiglottis because it has a column foot. And then there's something which I hope someone will be able to identify or see what it works for. In this kind of species, the Diosthenia group, some of them have a slit at the base of the column. Here, if you can see, this is the let's say the chamber of the cuniculus, but this here is very narrow. They sit side by, it's closed practically, and maybe you can get a tongue in here, but how that would work, I don't know. And then, of course, you have somewhere the column itself is very short, but it has a huge clinandrum hood, which certainly has some point in, this happens especially in Urstedella, the Urstedella group. So there is a great variation in the, and here is again, this is the rostellum slit where the viscarium was taken out. As far as the pollinarium is concerned, usually there are four pollinia, which are ovovoid, and the semi-liquid viscarium is always attached to it. But we have 3 species where we have 8 pollinia. They belong to a group from Colombia and Venezuela. And we have a couple of species which have only 2 pollinia, but in reality what we're seeing is the fusion of 4. It's very clear from this slit here that you had 4 and they're in the process of becoming fused. So again, it's not a character we can use to try to separate species as has been done in the past. The kind of pollinia are very variable. One type is what I call the bird wing type. The inner pair can be very small, probably also disappearing, whereas in some cases they're nearly the same size. And then you have the obovoid. And then in the case of the Epidendrum amphiglotium group, secundum, etc., you have a very curious architecture of the cauticles. So there are differences in every sense. If we go to the number of species which are recognized, here we have, as I say, by the last count, 2,152 species, of which Ecuador has 658. The reason I think is that Dodson was there for 40 years, and we all went into the field with him. This was heavily collected. It was peaceful. It was easily to get around. Colombia is now, according to my estimate, has 637. I think the official estimate is somewhere around 400. But the reality is that we couldn't go there into the field for 50 years because of the internal war. But now that you can get around, it's wonderful. It's incredible. You're going to find new species all over the place. And I'm very happy that there are very many young people collecting, especially in departments which had not been collected previously. Peru, sorry. Peru is interesting. I think the official number is somewhere around 200 and something. But we have one student who in one park has found 1,800 species. That's one park in Peru, Alto Mayo. Jose Dilmer Etienne is the collector. He's been collecting for 8 years. At first, he couldn't collect specimens. He could only photograph. We got him a camera. We showed him how to make all the photographic series to be able to make the plates. and now we're in the process of describing and trying to identify everything. So Peru is certainly going to have a huge number of species, but there are really very few systematic collections being done, as again, systematically, going into the same place for years, at all kinds of times of the year, and collecting at least orchids. Costa Rica is, according to Karremans, 247. Then comes Bolivia, which we have few things, but I think, again, it's under-collected. And Mexico and Brazil, I think, Mexico, I'm sure of the number. Brazil, I think that Edley has been one of the long string of people who have been reducing names into synonyms. So apparently we have very few species for such a large country. I can't believe it. And this is just an example of the species we have recently found in the Alto Mayo in Peru and have described. There are many which we have not described yet, but it's impressive to see the number of species which are coming out. One of the things that was used by Brieger, for example, he said, oh, all these flowers look alike, so we must put them into the same genus. And what happens is that these are sphinxid, pollinated. Yes, the flowers look alike. Here you have the pollinaria, and they're very typical of the nocturnum group because one side is flat, linear, whereas the rest is sort of a half circle. And this was taken from a specimen in a herbarium in a moth collection in Germany, which we published with Mosberg. And when you see these species here, the flowers look alike, but the plants are completely different. So later on, I'll have some questions there. But it's clear for us that this shape of flower has appeared 5 times independently within Epidendrum. So yes, it's a pollinator. It depends on the pollinator, and it can appear anywhere really within Epidendrum. So you cannot use that as a good to try to make a group or a genus or whatever you want to call it. As far as plant morphology is concerned, it's interesting because you have some things with pseudobulbs, some plants with a long rhizome, some plants are cespitous without a long rhizome, some are very short, some are very long. You have all kinds of things. Here you have 2 examples of something which nobody has discussed it with me, but normally Epidendrum is sympodial, which means that the plants renew itself, they have a new stem, and as long as the support is there and the climate is all right, they can live forever. There's no limit. But there are a few things in Costa Rica in particular, Epidendrum morarritana and Paraguastigma. This thing looks like a vanda when it's young. It has a large stem with huge leaves on the same plane. And the large leaves are lost, but eventually they branch out in secondary, tertiary stems, and they will all flower at the same time and the plant dies. So that's something which is, I don't know if it happens in other sympodial orchids, but in my case, we've used the term monopodial for this kind of architecture, which means you have one stem and then it branches up at the top, and it's not well, it's something which I would like someone who gets into anatomy to try to understand what it is. In this case, it's a hanging plant. The main stem, the primary stem, is very long. Then you have secondary stems, but the flowers come from tertiary stems, which can be produced either from the primary stem or the secondary stem. So that's as far as architecture is concerned. This, for example, is what Slachetko called genus Taculumena because it looks like a vanda, but the flowers of this thing are are exactly the same as this, and it has a very different architecture. And these things are monophyletic. They belong to the same group. So Tacculumena is not just a vanda-looking plant. It has other things. I don't get into the details. I don't have enough time. But finally, they're all within Epidendrum. Now, we've been doing, for many years, the ITS region. That's where we have the most number of species sequenced. And it's very interesting in the sense that we have been able to find, for example, the Mexican clade. Or is that the Mexican clade? No, I think the Mexican clade is up here. And this is Amphiglotium. Some are very easy to identify. This is the Deforme group. They form groups which are very clear, very easy to identify. The Ramosum group is over here. Their architecture, the flowers are very clear. But unfortunately, they don't help in identifying, in trying to separate species. In this case, we have in the Amphiglotium group, we have the secundum type flowers, the Orchidiflorum, and the Blepharistes group. They seem to be very close. And it's interesting to see that there are a number of hybrids in this group. Here, for example, you will find Orchidiflorum with denticulatum, which forms Purpureum. So these things, although they look different, the pollinators do get across. And then you have a very interesting thing. The people in Martinique and Guadeloupe have never understood the variety of the calli of Epidendrum secundum. I think this is what is closest to secundum. And recently, thanks to a nature photographer in Martinique, I was able to describe Cryptopateras. And this is the hybrid. And when you look at the type of Epidendrum elongatum described by Jacquin from a plant cultivated in Schönbrunn and said to have come from Caracas, if you look at the inflorescence here, it's exactly the same as this. Unfortunately, they illustrated a senescent flower, which becomes orange, but the original color is pink. And here you have the calli. I won't get into the details of how we get into this, how it varies, because I don't have time. And here we have something which I'm working on from, it all goes from the Guyana to nearly Bogota, 1,000 kilometers. And this is the hybrid of these two species, which are very rare. This is in Pacaraima near Tepequem. This one is where I collected in, but it also grows in Tepequem, in Camoirán, in the Gran Sabana from Venezuela. And curiously, Epidendrum gran sabanense was described from Camoirán, but it's a cross between these two. Epidendrum secundum, which doesn't grow rarely there, it grows on the top of the tepuy, but hummingbirds can come down, they fly a long way. And they've been all been identified as Epidendrum ivagense. So when you see our Brazilian friends using this to compare with other species, they call them ivagense. Nothing to do. This is a species from, here you have the whole range of distribution of what I will call Epidendrum communis. Unfortunately, I have no genetic information, or very little. I think we have sequenced one or two, but nothing which can be, but it's huge. The distribution is absolutely huge. I've seen plants in Tepequem, in here and here near Villavicencio, La Sierra de la Macarena. It's absolutely very interesting. The Ramosum group is very consistent, no problem. Some are hanging, some are this, some are that, but the inflorescences are always disticus. The plants are branching. It's a very easy group to understand. And then we come to the Mexican clade. The Mexican clade is a mess because we have two groups. One is the Anisatum group, which is very consistent, and then we have everything else. And everything else means things, this is the anisatum group, but from here to here, they all belong to the same clade, the same, yeah, this clade. So you have things with pseudobulbs and deciduous flowers, Epidendrum parkinsonianum, which is completely different. How did this happen? A few years ago with Miguel Ángel Soto, we postulated that the hypothetical ancestor would be Marmoratum. From here you have the basal growth and sometimes small flowers and sometimes losing the leaves. Then you have losing the pseudobulb, and then you have the new growth coming out from the middle or the top of the previous growth, and then hanging plants with pseudobulbs and Epidendrum nocturnum type flowers. And then, of course, Parkinsonianum, which has no pseudobulb and a very fleshy leaf. How did this happen? That's something which I think will have to try to understand to see. We know it's monophyletic, but we don't understand how the hell such a great variety of things have happened. And now we did the ITS, and as I say, it's very clear. And then we've been able to do what the lemons did, the anchored hybrid enrichment, and it also is consistent. And the plastomes are also consistent, though we have a very small sample. And we think that this is the original species from which Epidendrum came, but we don't know. Sometimes it falls inside, sometimes it falls outside of Epidendrum. And well, I'd like to thank all the people who have participated in helping us understand this, understand Epidendrum. A lot of you are here seated, and it's a huge challenge to try to make a infrageneric classification which is consistent and understandable, especially because of this Mexican group which is so diverse. So I would be very thankful if anyone has any ideas of how this can be explained. Thank you very much.
Thank you. Thank you for the presentation. We have time for questions.
Very nice and beautiful talk, Eric. Well, I think you know that we have found some incongruences, strong supported incongruences between ITS and plastic data sets. You think it will make something of these groups that you found, like Amphigolotian, Remosin, that are more consistent, or they keep the monopoly?
I don't know if Gerardo should try to answer this question, or Rubi, if she's around here. Rubi?
Well, I think that it is an admixture of factors here. Sometimes some groups might be recovered by all the data sets, but some others are not. But I think that it might be the few information in the ITS, or some other examples might be explained by other processes. Maybe in some cases we might even have other phenomena explaining incongruence. We are evaluating it, so yeah, I think that's multifactorial. I'm so sorry.